So we can also make bar plots and histograms. So in this example, we're going to look at class, the same thing that we've been using in order to get this color aesthetic to map. And because we also included inside geom bar the aesthetic color, then it's also going to map according to each one of the different values. So this is an example of an overuse of color. You obviously don't need to distinguish each one of these different types of vehicle with its own unique color. But it is a cool example of how, using basically exactly the same written script, you can very quickly generate a new plot. And again, we use this labs and X and Y in order to label all the axes. So really the only thing that changed between this scatter plot and this bar plot is changing this part right here. So that's pretty cool. We can also make a histogram. So here's an example of an error message you might get. So it says stats bin using bins equals 30, pick a better value with bin width. So if we try to figure out what's happening here, there's a couple of ways that you can do that. So obviously you can just type in help, right? And you can type in the particular geom plot that you're working with. So we can geom histogram and see if you let it autocomplete, meaning that like once you've started writing and then you click either return or shift, then it will add these quotation marks for you. If not, you need to make sure that you put them there. So this generates in our help tab the basically syntax for using a histogram in Ggplot. So we want to figure out bin width and bins. So I'll give you guys a second to kind of read over this, think about what error message it's trying to tell us, and I will scroll up. Okay, so basically when we look back at this plot, we can see that there are some points, some bins basically, that don't even have any data at all, which is why we got this error message that using the default bins equals 30 maybe isn't the best. So there's two different ways that you could change this. One, and I will just get rid of that. One, you can change bins. So by changing bins, basically what you're doing is you're telling RStudio how many bins you want in total. The other option you can do is you can change this to bins width and then set it equal to a value. So when we run this, basically what you'll see is instead of having simply 5 bins in total for the data, basically we've divided up the x-axis by 5. So we have a bin which would be going from 5 to 10, from 10 to 15, and so forth, all the way until the maximum number that's in your data set. So those are two different ways that if you get that histogram error, that you can adjust it. But again, remember, you can always look under the help panel in order to get some more information about any kind of error message you get. Okay, so now let's make a line plot. So we're going to use geom smooth. We'll see that we generated this nice plot. The cool thing about Ggplot is that you can layer multiple plots on top of each other. So after geom point, we're going to have a plus sign, and then we're going to include this geom smooth. And when we run this, what we see is we get a scatter and a line plot. This will be really useful when we want to make or add a linear regression. So we can do that in one of two ways. First, this is the easier option. We will call basically the same script that we did before, except for this time, inside of the parentheses for geom smooth, we're going to specify the method should be a linear model and that the standard deviation will be false. And so when we do this, we see that we get this nice linear model. If we change this to true, what you will see is that we'll get this little shading here, which indicates the standard deviation from this this slope, this line. We can also add a linear regression line to the plot by identifying the slope and the intercept using this coefficient command, COEF. So because the way that this geom AB line works is it basically adds a line to an existing plot, what we're going to do before we do any of the stats or calculations is we're going to save this variable fig2, and it's going to include this basically everything we had before in the above plot. So everything should be exactly the same between these two. We're just going to save it as a variable. So now we're going to use this new command, COEF, and then again we're going to specify it should be a linear model. We're going to identify the y and the x variables as well as the data. So when you run that, we will actually generate the results here in the console, and then we can use that and specify the intercept and the slope in our geom AB line. So basically we're going to call fig2, which we have already saved as a variable, and on top of that we're adding this line, and we are identifying the intercept here as well as the slope. So when we run that, you'll see that we generated very similar plots between both of these two options. The last plot that I will show you that we can generate in Ggplot, although there are many more options, but for this introductory tutorial, we will stop with the violin plot. So this will basically, actually, let's just run it. So violin plots are kind of like a box plot, except for it has a little bit more character in terms of how the data is displayed. So if you specify scale equals area, then the distribution of the data will influence the shape of the plot. And so this is another good way to kind of show how different categorical types of data are distributed, or the general range of the data.